Hello and welcome to another one of D's ADD videos. Today we're going to be looking at percentage yield or percent yield. And basically in percent yield what happens is we're looking at a chemical reaction. We're expecting to get some amount, but we actually get another amount. Okay? The amount that we expect to get based on mathematical calculations is called your theoretical yield. Okay? It's expected because of the molar ratio of the elements in the equation and the given starting amount of each reactant. One of them will be sufficient in quantity, but the other one will be limiting. So limiting means that we don't have enough of one reactant based on the chemical equation to match the amount of the other reactant present. One of the reactants will be in excess, but the other one will be insufficient to the other one. Okay. So there's two ways you can approach this to calculate your limiting reagent. In the first method, what you're going to do is you're going to be given grams of both reactants. So what you can do is you can convert the grams of reactant to figure out how many grams of that original reactant will it take to react with the grams of the other reactant. Alright. We're going to use the coefficients of a balanced equation here to determine the amount of the other reactant. Okay? So what are you doing there? You're basically saying, okay, I got this much of one thing, and I'm going to use the stoichiometric calculations. I'll show you an example here in a little bit. In order to go from one reactant to the other reactant. And that'll tell you how much of the other reactant you need. Well, you look in your beaker or your jar or whatever, and you don't have that much. You only have a certain amount. Well, if that's the case, then the one that you don't have enough of is called your limiting reactant. But if you start off with a certain number of grams of one, and it requires you to get a certain number of grams of the other, and you have way too much, then the one you started off with will be your limiting reagent or reactant. Okay? So that's basically what this is explaining here. Make sure you try to go through that in your head. And once you see an example, it'll be much, much clearer. And you can go from there. So once you have your limiting reagent, what you can do is you can calculate your theoretical yield. And you can calculate your theoretical yield by using stoichiometry, starting with your limiting reagent. Okay, remember we just figured out which one of these is limiting, and going to your product now instead of your other reactant. We're going to go all the way to the product, and the amount of product we have from this calculation will be our theoretical yield. Okay. When we do experiments, though, rarely do we get 100% of our what we expected to get. There's human error, there's whatever experimental error you encounter. So you only get a certain percentage of the total amount that you should have gotten. The amount that you get is a given value, usually from the experiment, and that's called your actual yield. Okay? That'll be given to you in the problem usually. Your actual yield. We just calculated your theoretical yield. That was when we did the stoichiometry over here in step 2. And if you divide the two, multiply by 100, you get percentage yield. Okay? There are other things they can ask you from these types of problems. They can ask you how much excess do you have. They can ask you, what is the limiting reagent and what is the percentage yield, or what is the theoretical yield. All these questions can come about. Or they can say, if I have this much of one reactant given this balanced equation, how much do I need of the other reactant? Things like that. All right? So make sure you check out the example videos. It'll make things much, much easier to go through if you follow this. The other method in doing this is basically you're going to look at the moles. You're going to do the mole ratio of each reactant to the product, and whichever one has the lowest mole ratio will be the limiting reactant. Okay? So I will go over both methods in my example videos. So make sure you check those out. More importantly, practice, practice, practice. Thank you and have a nice day.